on behalf of the scientific community, we are extremely nervous about what could happen. And I think it's very important that everybody realize that although everybody is nervous about their own vested interest, from our perspective, if something as dramatic as the sequester were to occur, it would absolutely devastate the American scientific community exactly at a time when other countries are investing tremendously.
Spending on research and development creates jobs now. The $22 billion of new money that was in the ARRA to NIH and NSF and NOAA and NIST and so forth created jobs. Many of those jobs are continuing. That's apart from the huge payback that comes over the long term from research and development. It is an investment in the truest sense of the word, and we should never forget that.
Over the next 5 years, we would expect sequestration to reduce federal R&D funding by about $58 billion. That's about an 8.4% cut over that 5-year period. Defense would take a slightly larger share of the cuts. Defense R&D funding would be cut by about $36 billion, about 9.1%. And here you see non-defense R&D funding. Non-defense R&D we'd expect to be cut by about $22 billion, or about 7.5%. That's under the balanced scenario. Under the imbalanced scenario, in which non-defense bears the entire brunt of sequestration, we might expect the cuts to be much deeper, on the order of 17.5%. Although, again, these are pretty unlikely, I would argue. But even in the most recent appropriations cycle, appropriators in both the House and the Senate, both Democrats and Republicans, actually did find some common ground on several R&D funding priorities. And some of those are listed here: NSF, DHS, especially DHS, NNSA, NIST, et cetera. Even given these tough fiscal times, the fact that we're still seeing some agreement in certain priority areas, it suggests to me again that we may well be much better off finding a deficit reduction plan that does get the nation on a responsible fiscal path, but better reflects some of these shared priorities that many in Congress, I know, still support.
Reduced funding for national laboratory user facilities would impact scientific and technological program and user communities, not only from the United States, but also from all over the world. National laboratory staff and external users from national laboratories, universities, and industry will have reduced access to these facilities and to the staff, and therefore curtailing the development of new frontiers in science and technology. And very importantly, we have to consider that funding for national laboratories, user facilities, benefits the entire portfolio of U.S. science and technology, as represented by funding coming from NSF, NIST, NOAA, DOD, industry, and many more other sources. So there is also an impact of the sequestration bill on national laboratories and universities' R&D programs that are impacting critical industries for the benefit of the U.S. economy. And U.S. industry benefits from investment in pre-competitive use-inspired science and technology research. And let me give you examples. The industries affected include advanced manufacturing, pharmaceuticals, a new generation of biomedical devices that can make a tremendous impact in the quality of life of people, alternative energy, and electrical energy storage. And let me give you an example on the last one. Many of you may not be aware that the lithium-ion battery right now in the Volt car manufactured by GM that is in the market is a technology licensed from by GM from Argonne National Laboratory. Now, computer simulations and theory we are doing and experiments are showing that if we can develop the next generation of lithium-based batteries called lithium sulfur battery, that may enable a 500 miles electric car. So this is huge. And if we don't do the fundamental and applied science we need to do, we may not get there, and that will impact one of the key industries relevant to the economy of the United States.
Let me turn to the life sciences. This is literally a transformative time in the history of life sciences. In any scientific endeavor, there comes a time when there's a transition from being able to observe and describe phenomenon to actually be able to elucidate mechanism and to manipulate that mechanism. That's where we are now in most areas of the biomedical sciences. And that detailed understanding of underlying mechanisms in health and disease is what drives discoveries that produce new diagnostic tools for earlier detection of disease and new therapeutics for more efficacious treatment of diseases. We got here because of the investments that have been made by the federal government in the federal funding agencies, and in turn the partnerships forged with the national labs and the research-intensive universities. All of the things that many of us now take for granted, the regular use of aspirin, the vaccines that have prevented some of the childhood illnesses that plagued earlier generations, the use of lasers, of a multitude of imaging technologies, new devices that hold the promise of curing blindness, advances in gene therapy, which have also been applied to congenital blindness. All of these have resulted from this very successful partnership that is at risk now. And there are many more that are just emerging. The ability, for instance, to harness your own immune system to fight invading diseases. The promise not just of developing vaccines that reduce the deleterious consequences of diseases, but actually prevent diseases, including cancer vaccines. The enormous potential of induced pluripotent stem cells for regenerating organs that have been damaged by diseases. All of these are the result of funding through the federal agencies and the partnership that drives innovation and discovery in this country.